This is a project from a fax machine, and since the fax machine didn't have a carriage that moved back and forth, this team instead used a stepper motor that was used to drive the roller forward. This is of course, it has two coils on it with center taps. The center taps are tied together, so you end up with 5 wires coming out. This group is driving directly off the amplifier chip on the development board, and they've used a capacitor as usual along with a variable resistor over here to control the position of the motor. Go ahead and reset the code, guys, if you would. The variable resistor is at about its mid position, so you notice, one more time please, you'll notice when the code is reset, what happens is the motor turns. You can see the LEDs indicating the phase of the motor coming out, or the phase being sent out to the motor. You can see that cycling. So now if we adjust the position of the resistor, the wheel attempts to track the position of the resistor. So some of the challenges these students had was figuring out how many steps there were per revolution for this motor, and the system is designed to accomplish 1 complete revolution of the wheel, although right now it's doing multiples and I'm not sure why. Did we keep it modified with +2, -2? Yes, we did. Okay, reset it. The reason is because I took it down to 0. We used a trick. We basically have a position and a commanded position, but the variable they're using is called prev, and that variable represents the current position of the motor. The variable position actually represents the commanded position from the potentiometer. So it's designed to accomplish 1 complete rotation of this large wheel for a complete rotation, or between the limits of the potentiometer. So as the potentiometer moves from one limit to the other, the wheel is supposed to rotate 1 complete revolution. It was working fairly well until I convinced them to modify their code. We're trying to keep the motor from jiggling back and forth due to the potentiometer inaccuracy. The resistance in the potentiometer can vary a bit, and so the motor tries to track that very quickly, and the motor can actually oscillate back and forth. So we tried to fix it in software and haven't succeeded so far. But overall the system works well. The output wheel, the white wheel here that I'm zooming in on, makes approximately 1 complete revolution, and of course the students had to figure out the gear ratio as well to figure out how many steps represented 1 complete revolution of the wheel. Did I miss anything, guys?
I don't think so.
So that's the system.